should be a professional pourer.
Make sure make sure that's out of the frame.
Yes, this?
Yeah.
Okay. Now we do have a little hole in this top, a little cut in that
See
one.
how insulated that
Yeah,
is?
that's amazing.
Yeah, it was cool.
I'm gonna go for a minute.
No, I wonder, on the double layered cup, unfancy regular cup, fancy regular cup.
Great lid placement.
Well, thank you. I did not bring beakers. This is doing it. Putting cold water in these two. Okay. And hot water. Very hot water. Does it show? Oh, well. Glad I'm not sitting underneath it. Okay. Now, here's the trick. We're going to put hot on the bottom, cold on the tops. I take this apart, turn this over, and pull. So cold on top, hot on the bottom. This one, we're gonna keep cold on the bottom. That one's not gonna work, you guys.
You got it.
Oh, got it? Okay. That one was hard. I didn't have gloves.
That's cool. That is cool. Did you see the hot Nice. 3 minutes later.
Yeah, so the one on the right has cold at the bottom and hot at the top. The one on the left are almost exactly the same now. It's hot and a lot of cold on the top. Whoa!
Yeah, that hot went up to the top and then equalized their temperature.
This is Warmy. You haven't met him yet, you haven't had a chance, but he's going to come up later in our weather unit. He is a warm air mass. This is where he is right now. This is down in Antarctica, and he wanted to hang out with the penguins. He's decided at 37 degrees Celsius that he's a little too warm, so he's going to jump in the water. And here he goes. And notice as he goes down, he's getting colder. He doesn't look quite as happy. Those little red dots there, those represent molecules that are hot, and the blue dots represent molecules that are cold. What do molecules do when they're hot and when they're cold? The hot molecules move really fast. The cold molecules move pretty slow, depending on their temperature. Let's take a look at two molecules, one hot and one cold, and what happens when they meet. Well, they exchange energy. The colder one became a little bit warmer, the warmer one became a little colder. And that's going to keep happening every time they come into contact with each other. They're exchanging energy. It's going to go from hot to cold. The hotter one is going to give energy to the colder one. And eventually, if this keeps happening, they're all going to keep exchanging energy and become more equal in temperature. But you'll notice there are so many more cold molecules than Warmy's warm molecules. And eventually, he's going to end up the same temperature as the water around him. You can see where he was. I think he's probably still there. He's way down in Antarctica. I think he's probably lost a little too much heat to survive. Hopefully, being in a warm air mass, he'll rise up out of the water and everything will be fine. Now that you know about what happened to the molecules in Wormy and the water around him, explain this. Explain this one.